Hello, how is it going? I'm so excited to hang out with you today and talk about some interesting things. My name is Tejas. That's pronounced like contagious. I'm not contagious though. Like I've tested negative multiple times, but contagious is the way you say Tejas, just to help you pronounce it. And I'm really excited to talk to you today. I am the director of developer relations at Zata or Zeta. We've kind of given ourselves a GIF or GIF problem. Anyway, like the goal of this company is to make databases easy for developers at all levels of scale. Like we just want to provide a really good developer experience such that when you reach for a database, it's something you can like throw data at and just not worry about ever. But that's not what we're here to talk about today. We are here to talk about building a massively scalable and performant Jamstack app in minutes. Building a mass. I mean, come on, this sounds like buzzwords. Really, you're making me say it? Nobody's making me. I know the title does sound a bit buzzwordy, so we'll talk definitions and clear that up. But before we do, I just need to give you a bit of a disclaimer. In this talk, I will mention like technologies and tooling that helps me developer experience wise. I need to be really straight with you. I'm not trying to sell you anything. The goal here isn't marketing, right? But more giving you an idea of what's available to you and kind of giving you an insight into the thought that goes into creating systems at varying levels of scale. And so sometimes you say, hey, I reach for Redis. Why? Should I use Redis? I'm not trying to say you should use Redis, but this is just a common tool that people use at this scale level. Okay, so again, the goal, this is not a vendor talk. I'm not marketing anything. I just want to like give you information over marketing. Okay, with that, let's go back. So what does this buzzwordy, clickbaity title mean? Let's talk about that. What do we mean by massively scalable? You know, across my career, as many of you, I've seen different scale levels of companies. I've worked for like tiny companies of like 7 people. I've worked for Spotify with like some 4,000 whatever employees. For the purposes of this talk, I've broken down the notion of scale into 3 S's to help us kind of identify different levels. And those are, the first one is seed scale. So this is a company that is just beginning. It's not yet maybe fully developed and so on. And you're usually building like proofs of concept here, pivoting fast, moving fast, breaking things, that kind of thing. Seed scale is usually more explosive, but also more shifty, I would say. Like your context is just all over the place. Number 2, startup scale. This is at the point where you have a few thousand concurrent users, maybe like 5 to 10,000 users weekly to monthly, something like this, where people are actually using your thing. You're a startup, there's money coming in, you're not maybe used by millions of users across the world, but you're still substantially used to the point where you care about monitoring, performance, testing, and things like that. Now, ideally, you care about these things at the seed stage, but if we're honest, we just usually at that stage want to get something running. And this is where we fine tune and add dashboards and look at things and so on. The third S is substantial scale. I mean, and this, it's as big as you can get, right? Like I used to work at Spotify. Some 4,000 employees, like at any given time, I think there was a number tossed around of like 300 million concurrent users just like listening to music at the same time. How do we handle things at that scale level? For the purpose of this talk, I've broken this down into 3 S's. Of course, it's not exhaustive. It's a simplification perhaps, but I wanted to help us guide the discussion with it today. Okay, so the title again: building a massively scalable and performant Jamstack app in minutes. Hopefully, we've dealt with the massively scalable piece. Let's talk about what we mean by Jamstack app. What is that? The Jamstack is JavaScript. So it uses JavaScript or TypeScript, which is a superset of JavaScript. It uses JavaScript to communicate with some type of API, usually a web-based API, to get data or do authentication or something like this, and serves markup to the users. This is literally the jam in Jamstack. What you'll notice here is the absence of like Linux or MySQL or like these database backend details aren't specified here to give you the ambiguity of choice. And that's why we focus on Jamstack apps here. And lastly, what do we mean by minutes? See, I could do an amazing like demo where I build you something that scales really well in minutes. I could literally do like a live demo here and then load test it and just slam it and show you, wow, this thing just works. But I think that really, I mean, it would help me. I would look super cool doing it, but it wouldn't really give you that much value. Like it wouldn't help you. So what if I do something like that and you're like, wow, that's amazing, and you leave here unchanged? That's so. What I want to do in our time together is talk about the thought that goes into being able to build these things in minutes. But I'm not probably doing it myself because that's just a massive flex, and I don't want to be that guy. But the goal of this talk is to shed light on the decisions we make at all stages of scale to help us handle these concerns off scale within minutes, and not months, years, and so on and so forth. So with that, let's talk about specific pieces of functionality that Jamstack apps have at different levels of scale. Because an observation I made kind of preparing for this is that Jamstack apps usually have similar functionality. I maybe would be bold to say every Jamstack app has certain things in common. These things are, number one, routing. Like apps have pages. Like you click a link, you go to another page on the app. Like I can't think of an app that doesn't have routing, except maybe like a meme maker. Okay, that's something maybe that doesn't have routing, right? Like you get an image, you put text on it, and so on. Okay, most Jamstack apps share this. You could draw like a Venn diagram, and routing is somewhere in there. Routing is a concern across Jamstack apps. We'll talk about how we can accomplish healthy, reliable, good routing for Jamstack/React apps at all levels of scale, at seed, startup, and substantial. Number two, deployment. Jamstack apps are used by people if they're accessible, as in if they're deployed somewhere in the cloud. We'll talk about what deployment can look like at different scale levels, and what we tend to reach for as we go towards the higher end of the spectrum. Number three, data. We talk about how data infrastructure can scale across companies through seed, startup, and substantial scale. Okay. With that, let's just start straight up routing. Routing is a universal concern. It would be quite hard to think of an app that doesn't have routing, that doesn't have multiple views or pages. If you're using React, you've probably used something like React Router and so on. But what we're trying to understand is the thought process behind thinking about a robust routing solution at all levels of scale for our Jamstack app, so that we can make a decision in minutes. To fully understand the complexity and not just choose something blindly. I've seen a lot of startups, a lot of companies that in the haste of let's just build a product, we don't fully think and understand the complexities of routing. And we kind of just choose whatever is popular in the mainstream. So I think this talk is a great opportunity to explore some of the nuance around routing by building it ourselves. Let's roll our own just to understand the complexity, and that'll help us then talk more about decisions around routing at scale, at seed, startup, and substantial scale. So with that, let me just share my screen here. You should be seeing my screen at this point, and let's just build like a poor man's router in React. So this is a new React project. As you can see, there's literally nothing. There's just some package JSONs and tsconfig. It's a TypeScript project. So what we'll do is we'll touch, as in we'll create two files, index.html, index.tsx. And we'll just open the editor here. And index.html because I prefer to use Parcel for this kind of thing. It's just a quick dev server. Again, I'm mentioning tooling. I'm not saying use it or anything. This is just for the demo, okay? So index.html. We need a root node. This is a React app we're creating. So we'll do something like this. And we'll reference our tsx file, index.tsx. Oh, and it's a module too, so we'll tell it that. Okay. We go to our TSX file. It's a new React app. How do we bootstrap a React app? Well, we should probably have an app, something like this, right? H1 hello. And then we'd need to render it. So let's get started there. Let's import React from React, and we'll import create root. This is the new React 18 way, fancy, from React DOM/client. All right, so what we want to do is renderer. We'll get this after we create a root from document.getElement by ID. We have an element with an ID root, right? So we'll put our app in there. We'll tell it exists, chill out, TypeScript. And we'll say renderer.render app. Okay. Let's run this just to see if it works. We'll do yarn parcel index.html. Okay, we should have something. Yeah, we have a React app. Not really special, but at least it's something. So now our goal here is to understand the complexities of routing. To understand that, let's add links is probably the easiest way. So we'll add a link to /about, and we'll say about, and then we'll add another link behind a pipe. I don't know, like contact. I'm just thinking of like the most generic stuff you can do. Okay, contact, done. So now we have these two links. We don't have a router, so we just kind of get nothing. What is a router? Conceptually, a router is something that looks at state, at location state, usually from a history stack data structure. It looks at some state telling the app where you are, and based on that piece of state, it shows you a view. That by definition is a router. It receives an address and then does something with the address. And like super hand-wavy abstract way, that is what a router is. You can route at the DNS level or the path level, whatever, but like it's something that gets state and based on that state returns something, okay, or does something. So with that, how can we do this in our little React app here? Well, we would need two components. We need a router, like the main contextual controller thing, and routes. Like at this path, show this thing. Let's look at how that looks in the code. So if we go here, what we'll do is we'll create these files. So we'll say router.tsx, and again, import React from React. I know I don't have to write this, it's just a habit. And we'll export const router. It's a function component that does nothing for now. Let's leave this blank, but we need a context. So export const router context. And this is, we'll create a context from React, and we'll say the current path is nothing. That's just a default state. And what we do here is we'll return the router contexts provider. The value is current path, which doesn't exist. We'll get there, and we'll put the children inside. This is new, but in FC with React, children is no longer implicit. So we'll say children is expected to be a React node. And we'll get that here. And also, we need an initial path for our router context. And it will just say it's a string. These are props, by the way. So now I get initial path here, and I can store this in state. So we'll say current path, and we'll set current path. We'll use state. The initial path is initial path. Okay, nice. So we have a basic router context. We'll use set current path for navigation and stuff as we need. We probably won't because of time. So we have a router. Let's wrap our app in this router, just like that. Router, we'll import that from /router, and it needs an initial path. Initial path in this case is window.location.pathname. This can come from anywhere, but for our purposes, we'll just use the window object. Looks good. So now we need routes. We'll create a new file. We'll call it route.tsx. And okay, we'll export const route. It's also a function component with children as a React node. And we'll destructure that and get it. And what we'll do is we'll return null by default, except if the path from the router context, so from the URL, if that path matches our existing route, then we'll show it. So how do we do that? Well, first we need to get the current path from the context. So we'll use context, router context, like that. Okay, so what we'll do now is we'll say if current path equals the route will get a path as a prop as well. It's triple equal to the path of the route, then we'll return the children. We need to make TypeScript happy, so we'll use a fragment here. I don't know why. Okay, so this looks good-ish, except what? What do you? I need to import React. I guess I do need it for parcel or something. Okay, so it works. Let's see how well it works. So what we'll do is we'll add a route somewhere here. We'll say route path is about. And in this route, I want to render stuff, at the about path. So I'll say paragraph, this is about me, and then I'll put a picture. to my GitHub address or my image.png, something like this. Okay, so that's one route /about. Wow, that actually works. And then we'll do another route for contact, and we'll just put maybe a link to my Twitter or something, right? Ahref twitter.com/TejasKumar_ Twitter. Follow me, by the way. Okay, anyway, so there, about, contact. Oof. So yeah, we just made a poor man's router. And so we kind of understand some of the complexity about router, but let's dig a little bit deeper because this is important. So now if I view the source of this file, what you will see is that none of this HTML actually makes it to the browser. How it works is the browser downloads JavaScript, and then the JavaScript puts the stuff on the screen. The problem with this is a search engine like Google, Bing, whatever, is just going to see this. If there's like an automatic screenshot taker or something of my site, it's not going to actually see the site. It's just going to see some random JavaScript. We can do better. This is where we need something like server rendering. How would we go about doing a poor person's server render basic seed router thing? Let's try. So for server render, you probably need a server. It's a good place to start, right? So new file, server.ts. We have Express, so I'll import Express from Express. Again, I'm mentioning the name of a tool. Hey, I'm not trying to sell you something. I'm not saying use Express all the time. I'm using it because it's free and I know it, but this is not a marketing talk. All right, let's go back. So app, if you've used Express, you need an app, which is like a server. So we'll do this. We'll listen on port 1717. I feel like it. And what we need to do is for like routes at /path, we get a request and a response, and we will, I just realized I need to rename this to TSX because I'm about to do some React stuff. So what we'll do is we'll import the server renderer from React. So we'll do this from React DOM/server, and we'll get the render to node stream, static node stream, and we'll essentially render a component and then pipe it to the response. But what component do we render? This is a great question. So if we go to index.tsx, we have this initial thing we render to in this case, to the DOM, right? We need to render that on the server and then send it over the network. So what we'll do, step one is we'll probably factor this out. So we'll call this like main or something. I don't know, main.tsx, export const main, and we'll do this, and we'll import our things as we need. So router and then app, I think we can just move the whole app straight. We don't need to export that for now. Okay, it looks good. I think we need to import React from React. Otherwise, this thing is going to give me trouble. So we'll import React from React. Okay, and then we just need to import the routes. I love TypeScript and autocompletion. Okay, so this is great. But window, if we're server rendering, window is not going to be available to us on the server side. So we can just parameterize it. We'll just say initial path here and then give it through the function. Initial path, it's a string. Great. And so now if we go to our index.tsx, we'll render main. The initial path is window.location.pathname as a string. Perfect. And then on the server, we'll render main. But instead of this, we'll do a leading slash and rec.params.path. Okay. I don't know, simple. So now let's go run that. The folder is literally called lol. So we'll ts node server. Yeah, let's do that. I really hope this works. Well, I think it's listening. So if we go to localhost /1717, cannot get, to be fair, we don't have an index. So let's try, what was it? About. Okay, that kind of works. Contact. Oof. But you notice it kind of looks the same as the client rendered one. But if I go here and view the source, you can actually see that there's a whole P and the image, and it's rendered from the server. In fact, I could run this whole thing without JavaScript and it would work just fine. Okay, we maybe spent a bit too much time on this kind of thing, but I really wanted to show you the complexities of routing. So if we go back, that's what routing looks like. That's what the complexities of routing looks like. Does this work at seed scale? Probably. It's hacked together. I mean, I can't deny it. This was just a massive hack. Does it work at startup scale? Probably not. If we have, even 100 users, we would not trust something this brittle. We would probably reach for something more established, something like React Router. Again, I'm not trying to sell you anything. React Router or Reach Router would be tried and tested. Why? Because it's open source and it's the maintainer's job almost. I don't know if they get paid for it. Probably not. Which makes it even worse. You should sponsor the project if you use it. But they spend a lot of time working out edge cases, ironing out kinks, making sure it works well. And so, of course, you trust that at startup scale. How about at substantial scale? If we think about routing, yes, you can get server-side routing with something like React Router. You can get client-side routing. But maybe at substantial scale, you're going to want to push stuff a bit faster. You might have a use case for static rendering. Static site generation is a whole nother, you can't, the way I just kind of went from client to server rendering, to do that with static sites is a bit more involved, right? Because you would need to depend on some type of convention to isolate pages and then generate based on, it gets complex. And so at substantial scale, is this going to work, or is the startup scale solution of React Router going to work if we decide at some point at such large scale that we need static pages? Probably not. Which is why we have the gift that is frameworks. Things like Remix, who Kent and the team are doing amazing work. Things like Remix or things like Next.js. Again, it's their whole deal to make these problems go away and help us build fast at scale. So this is where you would kind of identify, okay, maybe Next.js or Remix is something we would do because we now understand the nuance of routing across Jamstack apps. Does that make sense? All right, let's move on. That was routing. How about deployment? Jamstack apps are deployed usually to the edge. What does that mean? These web pages live on servers. I know it's called serverless often, but there are servers somewhere. The thing is, you just don't have to deal with them, right? So they're serverless for you. But when you deploy a static site to something like, say, Netlify or Vercel, what happens is it's built, you get static files, and those are served on CDN, Content Delivery Network nodes, so computers really close to your users. Because of the proximity, it loads fast. And because they're static, they're just text files, they make it to your user quite fast. If you have a server, things get complicated. So let's pause and talk now. Seed stage, can you get away with using something like Netlify or Vercel, or maybe even AWS S3 to deploy your site? Absolutely. There's a high chance it's text files or maybe some client rendered React app. Sure. At startup scale, how does that work with deployment? Usually you would deploy just like at seed scale, but if you maybe have a server with some more long running state, you deploy it to something like Heroku, maybe DigitalOcean, something like this. The problem is stateful instances are usually tied to a region in the world, like a data center, some geographic location. The most common region is US East. The problem with that is US East, because it's so popular, goes down sometimes. So can you imagine you're a startup, you're running stuff on US East, but US East is down. You lose money and time and customers are annoyed. That's a problem. You need, at startup scale, you'd need some type of failover strategy. You'd need some type of redundancy across regions. So that's something to think about. And then when you address that and move to substantial scale, maybe you'll want to execute serverless functions, but you'll want to execute them, at startup scale, you'll execute them however. In US East, it doesn't matter. Your users can wait a few seconds. But as you grow, you might want to squeeze every piece of performance out of your serverless functions. You maybe want to serve them closer to your users geographically here's a slide, from a CDN edge server. You can see here on the left, when served from a CDN edge, that is a computer closer to your users, the response time is way faster as opposed to using an origin server. So maybe you want to do this with your like serverless functions to get it to your users faster at substantial scale, while also enjoying the benefits of redundancy that CDN edges give you. In this case, I would probably reach for something like Cloudflare Workers or similar. And so now, if I'm building an app, seed or startup or substantial scale, I'm already kind of thinking Cloudflare Workers or something similar is on my radar to help me make the decision. And ultimately, we will, right? Number 3 is data. Data is probably the like most neglected, or rather youngest or least developed problem I've seen solved personally in the Jamstack world anyway. If you're a small, like a seed company at seed scale, how would you handle data? How would you handle having a database? There's some amazing tools out here that help you with this. I think of like Airtable for really small proof of concept type startups, or maybe startups with low code, no code users. The problem is it doesn't help you get very far. Like I think their limits are after 5,000 or something rows, you start paying and it gets expensive. And I don't know if you're a young company, maybe you can't afford that. In any case, I've had the privilege of working at like 7 people companies and at 4,000 people companies. And at every single company, data has been the hardest problem. To choose a database, to scale a database, and so on and so forth. And so what I want to share with you is some lessons learned from there in the hopes that you will be able to make a quick decision in minutes, and that decision will help you through all stages of scale. So I can share with you maybe narrative style, like a journey. If we look on the computer, I remember an early startup where we needed a database, and we chose Airtable in the beginning, but Airtable, eventually we outgrew it, and so we said, how do we proceed? We decided, let's use Docker and just stand up a Postgres database. And so this is kind of what we had. We just had a Postgres database, just like that. And so this was nice, it worked. It was quite read heavy. And at some point, we needed to scale. Like it was getting noticeably slow as more and more people started using an API that connected to this thing. So we used Postgres and had read replicas. So when a write happens, it goes to the main instance of the database, and that write is then propagated across like replicas, so clones of the database. And so when somebody wants to read the database, usually the one under the lightest load will respond to the user. It worked for a while, but then eventually it was still slow. Like, and this is, by the way, also after we scaled vertically. So we threw a bunch more RAM, more disk space. At some point, it was still slow. And then, we made the decision to include an in-memory key value store, a cache. I will not, I'm naming products left and right. I'm not trying to sell you anything, but we would add, in this case, Redis, just in front of the database. And it kind of works like this. So you have Redis here, right? And how Redis works is if your user sends a request to Redis first, Redis will be like, do I have this? Do I not? It's either a cache hit, meaning Redis has it, or a cache miss. Redis has no idea what this is. In case Redis doesn't know, it'll get it from the database. This will be slow because it's reading from a disk. But once it does, Redis stores it in itself, and then it's faster to read from and write to because it's in memory. And with computers, RAM is faster by design than disk. So this is the next evolution of our thing. And this is kind of what we had actually at startup scale. So we went from seed scale, something like Airtable, startup scale, this is what we had. And it worked, again, to a point. And as you start kind of thinking about substantial scale, what decisions do we face now? I think a big one is search. So if you have something like Smashing Magazine, like a blog or something like that, usually people would want to search. So you'd need a search engine. You'd need so if I go here and if I type search, you'd need some type. Elasticsearch is a great example. But now, how do you get data from your database into your search engine? Where do you even do this replication from the database to the search engine? You'd need some type of queue. You'd need here. So let's add a queue. We can maybe it's a Kafka queue. You could use RabbitMQ. You could use whatever you want. But some type of queue that would allow you to stream data from your database and then propagate it in a search engine. And of course, you'd need to maintain the connection state between them. You'd need to monitor them. You'd need to make sure things are running. This becomes very complex. Moreover, you'd have to deal with regional failover again. So this is all great, and maybe this cluster is running nicely in Europe, but then you need to have the same thing in US East. You need to make sure they play nice. You need to make sure if there's a regional outage that your users don't notice. It's quite complex. And like for routing, we had options. We had Next.js, we had Remix, we had React Router. For deployment, we have Netlify, Vercel, S3, Cloudflare. The database space, there's not a lot, right? There's things like PlanetScale, which fantastic product that helps you at a certain level of scale, like YouTube's level. There's Airtable for like low code, no code proofs of concept. But I'm failing to identify a product where it just helps you through all stages of scale. It doesn't matter if you come from a seed or a startup or substantial scale. You put your data in it, you access it, and it gives you these guarantees out of the box. Like something that gives you a guarantee instead of even a product. Like a team that would maintain all of this for you, right? We noticed here that this area hasn't gotten a lot of love in the industry, and that's literally why Zara exists. Like, this is the problem we're trying to solve. The goal being it would enable developers worldwide to build Jamstack apps at massive scale with performance out of the box in minutes. Like, so on your journey of creating a massively scalable performant Jamstack app in minutes, if you think about routing, sure, you can in minutes. If you think about authentication, sure, you can in minutes. If you think about deployment, sure, you can in minutes. Data is the one bottleneck that we're working to remove. With that, let's get back to the slides here. So what takeaways do we have? We've been talking a lot. Hopefully I've shed some light on the thinking and decision making that goes into building apps for scale at any level of scale. Let's talk about takeaways. What can you leave this presentation with that will help you on your journey? Number one, wheels do not need reinvention. Because of the open source world, right? There's so many wheels today that are smooth and proper. Like wheels like React, Svelte, Vue. These are wheels, and they're not the same wheel. Like, they're nuanced, they're different, they solve different problems in different ways, so they can coexist. But like, I wouldn't start creating my own library for building UIs. There's plenty of wheels to choose from. They're all relatively smooth, so why would I reinvent it? I would make the case that as you leave this presentation and go back to your startup or whatever it is you're building, I'd encourage thinking more along the lines of, is there a smooth enough wheel for this? Or do we need to reinvent it? Like, heaven forbid you implement your own routing. You know what I'm saying? Like I just did, like this hack project. They say never roll your own crypto. I'd say look for smooth wheels generally, and maybe don't reinvent one unless you really need to. Number two, product focus is the goal. Like, if I'm building Tinder, Bumble, some dating app maybe, I really would hate to spend, like, if I have 10 hours to build this app in a hackathon, I would be so sad if I spent 6 of those hours figuring out the data infrastructure. If I spent 3 of the hours choosing like NoSQL, MySQL, your SQL, everybody's SQL, like, I want to build my app. And so as you leave from here, I want to leave you with the takeaway that that should be kind of the canon, right, by which we make decisions. Like, does whatever we're about to decide help us focus on and build a product, or hinder us from focusing on and building a product? This, like, tool choice should consider that. Engineering teams, I feel like, should consider that. Why? So that the product is actually built in a healthy way, relying on the shoulders of giants that have gone before you that build things like routing and authentication and so on already. Number 3, and this is the last one. There's an old adage: make it work, then make it right, then make it fast. I agree, and I actually build things myself this way. I would just add, just for the context of this talk, we want to typically make things work and make them right and make them fast at multiple levels of scale that we can foresee, as opposed to just for right now. Because what works and what is right and what is fast right now at seed scale maybe is going to bite us at substantial scale. So yes, I love this framework, but I'd suggest considering it more in the context of scale. We're almost done. There is one more takeaway, but it's more philosophical, so I figured I won't do a slide for it. There's a Danish philosopher, really, I mean, who lived a long time ago. His name is Søren Kierkegaard, and everybody thought he was insane until he died, and then they kind of started to consider him a genius. Regardless of what we think of him, he had a really great idea that he talked about. This idea of reverse engineering. Like he would say, he would live life today based on his consideration of his last day. So he would think about then, and that would inform his now. And Steve Jobs had a similar thing to say at one of the Stanford addresses. Why do I bring that up to finish the talk? Because I see building things at scale this way. Like we reverse engineer our product in the context of scale. If we choose a router, we think, hey, is this thing going to work at substantial scale to the best of our ability? Like we can't foresee everything, of course, but from what we can foresee, should we roll our own router or use something like Remix? So like reverse engineering, but in the context of scale, is kind of the last takeaway. And with that, hey, I just want to say thank you so much for putting up with me for a while. I really appreciate it. There's some social links here, and of course, I'd appreciate a follow and a discussion. Thanks again for watching, and I'll catch you in the next one. Peace.